Okay, so now I'm going to explain what molar volume is. This is part 5 in your notes. So basically, we can use Avogadro's hypothesis to apply to gases when we're talking about them being at STP. So that's standard temperature, which is 0 degrees Celsius, and standard pressure, which is 1 atmosphere. This will contain the same number of molecules at the same volume, regardless of what the gas is. So there is this conversion factor where 1 mole is equal to 22.4 liters. So we'll just go ahead and write that down. That's going to be important. So 1 mole is 22.4 liters. That means that 1 mole of gas, regardless of what it is going to take up 22.4 liters of space. Okay. Now, there is something really important that we mentioned a little bit earlier in the year, but I really want to refresh here. There are 7 what's called diatomics. So 7 diatomics. If you know anything about prefixes, this di here means 2. You see the word atom in here, so that means 2 atoms, okay? So they come in pairs, essentially. So these 7, they are, so we have H2, N2, O2, F2, Cl2, Br2, and I2. Now, I wrote these in this certain way here because if you look at the periodic table, they basically make the number of 7. If you look at nitrogen, oxygen, fluorine, chlorine, bromine, iodine, just going to remind you there's 7 of them there. They form that number. The only thing that's tricky is you have to remember hydrogen since that doesn't go with the others, okay? It's a little further in the periodic table. Whenever I give you a problem, though, and I ask you how much space does whatever moles of nitrogen occupy, remember that it's N2, especially if I give you grams, that's going to come into play there. So this first example is a practice with that. So it says a sample of oxygen gas is a volume of 2.5 liters at STP. How many grams of oxygen are present? So when I ask you how many grams of oxygen are present, keep in mind that oxygen is going to be written as O2, not O. Okay, so remember that we've got 2 of them there. All right, so we're going to start again with what we're always given here. So in the problem, I'm given that we have 2.5 liters at STP. That STP means we can go ahead and use this number right here, which is only true at those conditions, standard temperature and standard pressure. Then we're going to go ahead and ultimately try to find the number of grams. So we're going to start with what we're given, so 2.5 liters times, since we've got liters here, we want liters here. The conversion can take us from liters to moles, and that number we're looking at is 22.4. Again, that's the one we just talked about here. Then we are in moles because these liters will cancel here. Since we have mole on the top, we're going to want 1 mole on the bottom. Since we have O2, we're going to want to put its molar mass in here. Each oxygen, if you look at the periodic table, is 16.00 grams per mole. And we have 2 of them, so we're going to multiply that by 2, which takes us to 32 grams in 1 mole, which is already on the bottom here. So now our moles will cancel. We're going to take the 2.5 times 32, divide it by the 22.4. We are looking at 3.57 grams. At this time, you're going to try the next example on your own, which looks similar to this. You're going to kind of go this way instead. So you're going to go from grams to liters. Use this conversion factor here, which is a new one. You will have to find the molar mass. Again, keep in mind that these are the diatomics here. So if the next question asks you about any of these, remember they come in pairs.